Hi everyone. In this video, I'm going to be walking through activity 3-4 titled Creating a Replication Group. This is from the MCSE/MCSA Guide to Microsoft Windows Server 2012 Administration in preparation of Exam 70-411. In my edition of the book, this activity begins towards the bottom of page 92. So quick background about the activity. In my previous video, I walked through creating a basic DFS namespace, which kind of points your network users to the shared folders they're trying to access. And that's great, but that doesn't create any kind of backup or any kind of secondary source for that data in case that server goes down. So I'm going to preface this entire video with the need for actual backups. You can set up DFS Replication, and it acts as a pseudo backup, but you don't want to rely on it entirely. At some point in your network, you want to have some kind of external or off-site backup for your data, for your user data in particular. This is great for access. If one server goes down, the data is still available on the second server, so users don't lose everything and they can continue working. But if my DFS replication is occurring between two virtual servers that are hosted on the same physical server, and that physical server dies for whatever reason, then it's really important to have some kind of external or off-site backup so you don't lose all of this data. So the replication group is more for the user end to still be able to access and work on things, but it's not a true backup. Don't count on this being your backup for your network. As we go through this, we'll get to a certain point and I'll explain another scenario where counting on this as your backup is a really bad idea. So we'll get to that. For now, let's just go ahead and jump into the activity. So we're creating a replication group between server 1 and server 2. And this is different from just a DFS namespace, a basic share through a DFS namespace, in that users will access data on server 1, and as long as server 1 is the primary, then any changes they make, any new data they add to their files, any new files they create, all of that data will be replicated, copied over to server 2. So that way server 2 will be our secondary, and so if server 1 goes down, the DFS namespace will still point to server 2 to access the data, so the users will be able to continue working on those files. So to begin, we need to set up a shared folder that we'll use for this. I'm just going to call it replication share. We need to go ahead and share it. I'm going to say everyone with read access. In your real environment, they'll probably need read-write access, but you might want to do that on a per-user basis, not just apply it to everyone. So we have that shared, and I'm going to come in here and create a document. We'll call this replication document 1. There we go. Replication document 1. And we want to do the same thing on our secondary server, in my case server 2. New folder. Go ahead and share it. And then come in here, and I'm going to vary slightly. I'm going to create replication document 2. So here I have document 2. On my primary, I have document 1. And so this is why it's kind of important to set this up with no data inside of your secondary. We'll see as we go through and set up this replication that the data in server 1's share will completely overwrite the data in server 2's share. So this will show how that copying takes place, where it'll completely replace something. In this case, because the folder names are the same, server 1 folder will completely overwrite server 2 folder, which includes the documents contained inside the folder. So let's go ahead and get started with the replication group. I'm going to open up our DFS management console and select replication. We can see that we only have the domain system volume, which is the initial default, which should point to the sysvol, which is fine. We're going to create a new replication group here. So to begin, you're given two options. You have a multi-purpose replication group and a replication group for data collection. I am going to go ahead and do a multi-purpose by default. It is selected. The second option it mentions here, it's between like a branch server and a hub. Like a primary server would be in your main office, and then your branch server would be, you know, a remote server probably. So that way, data that branch does, any files they work on and create, that data can be transmitted back to the hub. So that way, your main branch will have access to all of that data, whether it's user accounts or user data, whatever the case may be. We're not doing that here. We're going to stick with the default multi-purpose option. We need to set up a name for the group. This name will show right here under our replication. So let's go ahead and call it replication share group. Depending on your network environment and how you're setting this up or what purpose you're setting it up for, you may put an optional description in here. I'm going to go ahead and leave it blank because I don't really have anything to put there at this point. Here we want to select the individual servers that are going to be a part of this group. So I'm going to add servers 1 and 2. And it's going to go through and make sure that the DFS service is running on both servers, which it should be. And this should only take a moment or so. Alright, we're going to hit next since it identified both of those as functional. Here we have a few options. Our first, hub and spoke, is grayed out. For a hub and spoke, you need a minimum of 3 servers. As you can see by the picture over here, you're going to have one primary that then propagates data out to all the other servers. Since I've only got 2 servers, I can't set up that type of topology. This is a good topology for, I'd say up to like 6 or 7, probably, depending on your environment and your network capabilities. So that way you have one primary, and then you have a lot of secondary and tertiary servers. So that way each department, if you're in a large corporation and you have 6 or 7 different departments, each department can access the data on a different server and then compile all of that back. That way we don't have everybody accessing or attempting to access the exact same data from the exact same server, because eventually that server would be overwhelmed with the amount of requests to update data and everything. So this is good for kind of spreading out the load from multiple departments accessing data. It's also really good if you have one department that is actually changing and creating data, and then maybe your second department just needs to be able to pull up that data and review it, or maybe print out invoices. So whatever the case may be, there's a variety of ways to set that up and use it in your network. The full mesh is going to be the option I select for this video. It is a lot more taxing on your network. There's going to be a lot more traffic, and it's going to increase significantly every time you add another server to the group. So when I have just 2 servers, it's just data back and forth. As you see with 4, it goes from 1 to all of the other 3, and it's 2-directional, so everything's talking to everything. You can see that by the time you get 7, 8, 9, 10 servers, that all of them are talking to each other. So each one is talking to all of the other 9, and so on and so forth. It creates a lot of network traffic to complete all this replication. So I think they mentioned here, it's recommended when there's less than 10 servers in the group, just because of that network limitation. I would go as farther and probably say, depending on your network, probably 4 to 6 would be about as many as you would want in a group for that. But we can also go and look at how much bandwidth we're going to allot, and we can kind of control the network impact. No topology doesn't actually mean no topology. It means that you're going to create a custom topology, something that fits for your network. So we're going to select full mesh and continue. And here's where we can kind of control the impact on our network. Our first option is to replicate continuously using the specified bandwidth here, and you can set a limit, whatever the case may be, whatever your network can handle. This is really good in that as soon as a user makes a change or adds a file on the primary server, the primary server will immediately attempt to copy that to the secondary server. So if at any point your primary server goes down, then the vast majority of their changes in data for that day will already be on server 2. So that's a good pseudo backup internally. Again, it does not take place of an external or an offsite backup. I can't emphasize that enough. It is better than nothing, but you really need to get some kind of other backup system in place. Okay, so our second option is to replicate during specified days and times. For example, we could set this up to replicate when we know all of our users are taking a break, if they're required to take a 15 or 30-minute break at a specific time, and that's scheduled for everybody at the same time. You could use that specific time for replication. You could set lunch hour or half hour, whatever the case may be for your company. You could set their lunch break as another replication if they have a break in the afternoon that everybody takes. And again, you want to try to set those up for times when nobody's going to be working on that data and when nobody's really using the network, because this can become very network intensive very quickly, especially if they're dealing with large files or you have a large number of users making small files, just because you end up with fairly large amounts of data that have to transfer. So the downside to this is if I have my replication set up to run during their lunch break, so they come in at 7:30, 8:30 in the morning, and they work all the way until 12, 12:30. So you have 4 to 5 hours of work, and right as this replication begins, this server goes down. Well, that data was never replicated to the other server because I hadn't completed a replication process yet, so all of that morning's work has been lost. So again, between these two, you really need to analyze your network and see what your network can handle. I would generally recommend setting it continuously and putting a bandwidth limit on it. For the purpose of this video, I want to show the changes as soon as possible, so I'm going to leave it continuous with full bandwidth, and we will continue. Here we're going to select our primary member. If we look back at the topology, this is also important for the hub and spoke because we can see our primary member up here at the top. In the full mesh, you're going to select a primary member, and that one's kind of going to be the control for all this data. So in this case, I'm going to select 411 server 1. And earlier I mentioned that when I got to a certain point, I was going to talk about another way that could result in some data loss, and we're at that point now. So if I have 411 server 1 set up as my primary server, and it goes down for any reason, so my users are no longer accessing data on server 1, they're going to be accessing their data through server 2 instead. So they're going to be making changes, adding data, creating new files. All of that's going to be happening on server 2. So then server 1 comes back online, and 99% of the time, server 2 will temporarily take over control and copy the new data to server 1, and it'll work out flawlessly, there's no problems. But occasionally, you'll see that server 1 comes back online and immediately starts a replication service where it takes all of its data and overwrites server 2. Since server 2 is where everything's been happening since server 1 went down, your users are going to lose all that data since server 1 went down. Again, that's not a common thing, but it can happen. So you want to keep an eye if one of your servers go down. You want to make sure that doesn't happen, so your users won't lose any work they've completed. So we'll continue. Here, we're going to select the folder that we're going to be replicating, so we need to add. We're going to look at our primary first from server 1, and we're going to select that replication share. You can leave the name the same, or you can use a custom name. For this, I'll just call it custom share so we can see that. You do have the option of specifying different permissions. You can use the existing permissions, which we set up so that everyone had read access. You can do custom permissions, and you can literally set that individually per user, per group, however you want to do that for your network. For the video, I'm going to use the existing just to make things simple. Alright, and then we're going to go ahead and hit next. And now we need to point to where that server, or where that folder is on server 2, where we want it to be replicating the data from server 1 to this location. So we're going to edit server 2. We're going to enable it so that it can handle replication. And we'll identify the location right here. And so we can review all of our settings. And here we want to take a quick look just to remind us that on server 2, we have that share with document number 2. So once we create this and it starts replicating, you can see that it should be replicating here shortly. Since there's not much, this really shouldn't take very long. But once it starts that replication process, because the folder names are the same on both servers, the folder from server 1 will completely overwrite the folder on server 2. So instead of ending up with document 1 and document 2 here, the entire folder is going to be overwritten, and we're only going to have document 1. So when you initially set this up, you either want to use an empty folder on your secondary server, or you just want to have it create a brand new folder with the replication process. Because if you're using the exact same folder name and there's already data here, it will end up being deleted. I don't know why this is taking so long. There's really not much data there, so this should be really quick. If it hasn't done it yet, I might pause the video until I see this replication occur. And that way I keep this video as short as possible. So I'm going to pause for a moment. Once I see that replication occur, we'll come back and verify. Alright, so it did take a few minutes. So from server 1, I have document 1, and server 2, I now have document 1. So it shows that it will completely override anything if the folder names are identical and there's anything on your secondary server. Your primary will completely overwrite that entire folder. So again, that's just something to be aware of when you're setting up this replication. So another way to verify that replication's occurring, let's go ahead and open it up. We're just going to put in some test text, save it, and close it. We're going to come back over to server 1, let it reload, and hopefully replicate quickly. And within a couple of minutes, we'll see that that text has been copied over to this document. While we're waiting for that, we're going to go ahead and create a new text document, and we'll call this document 2 again. So then when we come and see, there we are. So replications occurred already to server 2 to create document 2. Just seems to be a little bit slow. to replicate the text inside this document. In any case, eventually it'll replicate data from one server to the other, back and forth as needed. So anything created on server 2 should eventually be copied over to server 1 as long as it's brand new data without overwriting anything. Even in some cases, because the modification date will be more recent on your server 2, because this is where the change was made, that will usually prompt it to overwrite what's on server 1. And then, of course, anything created on server 1 will be replicated to server 2 as that pseudo backup. As always, if you have questions, comments, or concerns, please feel free to leave them for me below, and I will see you in my next video.